Okay, so today we are looking at a new module in our mechanics, which is CG&MI, Center of Gravity and Moment of Inertia. First, we will see how to find the center of gravity for standard laminas or areas. The first is very basic, which is our rectangle. The area of rectangle is given by height, suppose, and breadth, h into b. So for this symmetrical figure, the center of gravity lies exactly at the center of the lamina, and it is given by a distance. It can be obtained by a distance b by 2 and h by 2, where b is the base, h is the height. So this is our point G at the center. The next is triangle. We are considering a very basic right angle triangle which has an area of half base into height. For this triangle, the center of gravity is located at point G. This point is obtained by moving to a distance of h by 3 and then a distance of b by 3, which is 1/3 of the height and 1/3 of the base. So we reach to a point G, which is at which the entire mass of the lamina is supposed to be concentrated. So this is our point G. The next standard figure is the semicircle. Area of a circle is pi r square, and for a semicircle, it is the half portion is neglected, so we have pi r square by 2. For this area, the distance d of center of gravity from the center of circle is 4r upon 3 pi, where r is the radius and d is the distance of the point G from the center of the circle. If we partition it into two equal halves, we get a quarter circle which has an area of pi r square divided by 4. For this circle, if you consider the entire circle with a radius r, the center of gravity G for this quarter circle from the point O, which is the center of the circle, is given by a distance d, which is again 4r upon 3 pi. Semicircle and quarter circle, we have the same formula to calculate the distance. Suppose we randomly, these are standard figures, but suppose we take a sector randomly from a circle, the area of this sector is given by r square alpha, where r is the radius of the circle and alpha is the angle, which is the half of the total subtended angle. If this angle is 2 alpha, this is divided into two equal halves, so we get angle alpha on the upper side and angle alpha on the lower side, and the point G is obtained by traveling a distance of d from the center of the circle, and the d is given as 2r upon sine alpha, 2r into sine alpha upon 3 alpha. So this is the method of calculation of point G from any of the surface that we have in our standard figures. But in our university questions, we will never encounter such simple areas. We will always get combination of these surfaces. Suppose we have a figure something like this, a rectangle with, suppose we have a quarter circle here, and we have a triangle as well. and these figures, the dimensions of these figures will be given. So 1, A, B, C, E, F, and G. And all these distances will be mentioned in the question. What we have to find is the center of gravity of the entire system. To calculate this, we have simple formulas. What we do is we find, using these formulas, we find the center of gravity of each of these standard figures, and then we have a formula: x is equal to summation of ai xi upon summation of ai, which is the x distance, then this ai is the area of each of these laminas or figures. So we take the summation of each of these individually here, ai and a1 into x1 plus a2 into x2 plus a3 into x3. For that we have, this is a1, a2, a3. So we can take all three of these upon the area of each of these standard figures individually. It is clubbed together. We take the summation of that as well, and we get our first coordinate, which is x. Now, for the y coordinate, in the same, using the same formula, which is ai yi upon summation of ai. Now you'll be wondering, what is this x and y? This x and y are the location, give us the coordinates of the point where the center of gravity of the system is located. Suppose here I draw. Suppose this is our 0 x-axis and y-axis, and this is the system. It is assumed that the system is placed in this manner. Right at the origin we have this point A, and the system is placed. So we'll travel a distance of x in this plane, in this direction, and travel a distance of y upwards, and somewhere in the center of the entire lamina we'll find the point G, which will be the center of gravity of this system. So this is what we have for the laminas. Next we will look at the lines or the beams. How do we find the center of gravity for a beam? That we'll see next.